thin film is a layer of material ranging from fractions of a nanometer (monolayer) to several micrometers in thickness. The controlled synthesis of materials as thin films, a process referred to as deposition, is a fundamental step in many applications. A familiar example is the household mirror, which typically has a thin metal coating on the back of a sheet of glass to form a reflective interface. The process of silvering was once commonly used to produce mirrors, while more recently the metal layer is deposited using techniques such as sputtering. Advances in thin film deposition techniques during the 20th century have enabled a wide range of technological breakthroughs in areas such as magnetic recording media, electronic semiconductor devices, LEDs, optical coatings such as anti-reflective coatings, hard coatings on cutting tools, and for both energy generation, for example thin film solar cells, and storage, thin film batteries. It is also being applied to pharmaceuticals, via thin film drug delivery. In addition to their applied interest, thin films play an important role in the development and study of materials with new and unique properties. Examples include multiferroic materials, and superlattices that allow the study of quantum confinement by creating two-dimensional electron states. The act of applying a thin film to a surface is thin film deposition, any technique for depositing a thin film of material onto a substrate or onto previously deposited layers. Thin is a relative term, but most deposition techniques control layer thickness within a few tens of nanometers. Molecular beam epitaxy and atomic layer deposition allow a single layer of atoms to be deposited at a time. It is useful in the manufacture of optics, for reflective, anti-reflective coatings or self-cleaning glass, for instance, electronics. Layers of insulators, semiconductors, and conductors form integrated circuits, packaging, that is, aluminium-coated PET film, and in contemporary art, see the work of Larry Bell. Similar processes are sometimes used where thickness is not important, for instance, the purification of copper by electroplating, and the deposition of silicon and enriched uranium by a CVD-like process after gas phase processing. Deposition techniques fall into two broad categories, depending on whether the process is primarily chemical or physical. Thin film technologies are also being developed as a means of substantially reducing the cost of solar cells. The rationale for this is thin film solar cells are cheaper to manufacture owing to their reduced material costs, energy costs, handling costs and capital costs. This is especially represented in the use of printed electronics, roll-to-roll processes. Other thin film technologies, that are still in an early stage of ongoing research or with limited commercial availability, are often classified as emerging or third-generation photovoltaic cells and include organic, dye-sensitized, and polymer solar cells, as well as quantum dot, copper-zinc tin sulfide, nanocrystal and perovskite solar cells. Thin film printing technology is being used to apply solid-state lithium polymers to a variety of substrates to create unique batteries for specialized applications. Thin film batteries can be deposited directly onto chips or chip packages in any shape or size. Flexible batteries can be made by printing onto plastic, thin metal foil, or paper.